Stem rust. So you want, for live samples of stem rust to then subsequently do race analysis. 5 to 10 infected stems. Cut 3 to 4 centimeter of stem. Take out the core stem tissue, just leaving the infected sheath. Why you do that? With the samples, the live samples for all of the rusts, dry. You've got to dry samples. It's critical if they're going to be viable for analysis. Yeah? So that core stem tissue has moisture, retains moisture. If you get rid of that, then your sample's going to dry much quicker and much easier. Yeah? And we'll do this in the field. Put it, same reasons, paper or glycine, yeah? Do not put your samples into a plastic bag. If you do that, you'll get moisture forming in the bag. Your samples will be not viable, okay? Dry your samples. So if I go out on survey, I usually end up maybe in a hotel room in the evening. So the room can be just full of samples with the envelopes open, just air drying. Yeah, I always wonder what the cleaners think when they come in and just see this, you know, mass of sample envelopes scattered all around the room. Send the samples once you've collected them as soon as possible. Yeah, you need to get your samples. So you've collected them, you've dried them. You need to get them for analysis, I would say, within 7 to 10 days maximum, if you're going to stand a good chance of getting viable samples. So if you're sending internationally, use couriers, you know, DHL, FedEx, that can go very quickly. Yeah, not relying on very slow mail systems. Even with these guys, they can take many days. We've had samples, I think, from Bhutan that went, I don't know, twice around the world before they actually ended up in the US. I mean, they just went on this world tour. Really important is you need permits and permissions for sending live samples. You can't just, you know, on a whim send a live sample to somebody without having the right permits. We don't want to spread, you know, dangerous races to different continents, different countries. You need the permissions. And we've got a protocol document which is accessible. It's on the web. Stripe rust, live samples. So take single leaf, fold it on itself, yeah? So pustules on the inside, put one leaf into a glycine or a paper bag, yeah? So that'd be one sample. And label the envelopes, yeah? With all the samples, actually labeling your envelope is critical, yeah? You do a survey, you've got 20 samples, you come back, you don't put any labels on them. Ah, where was this one? What was this one? Where was it? Yeah? You've got to label your samples when you collect. It's critical. So, labeling, yeah? If possible, I would put that information on your label, on the envelope that you collect a sample. At least put, you know, date and a unique code. And that same unique code I would include on your survey form, or in the tablet there's an option to put in a code. Viability, I've already said about this, but I'm going to hammer it home, yeah? If the samples are going to be useful, they've got to be viable. Dead samples are, well, we can get DNA, but live samples are much more valuable. It takes time and money to collect a sample, yeah? So let's maximize our efforts on this one. We've still got problems. I mean, looking at the data that Mogen's put out, 2014, 6 out of the 16 countries that sent samples had 0 viability. So So 40% of the countries that were sending samples, there were no viability when they reached the lab in Denmark. We need to do better than that. If you follow the protocols that are there, then you can get viable samples, yeah? And if you take away anything from this talk, take these 2 points, yeah? Samples are dry, so they're in paper or glycine, and they're dried overnight at least, or, a couple of nights. And they're sent for analysis as soon as possible. You don't leave them sitting around in your office for 3 months, and then you expect to send them to a lab and think that they're going to be viable. Yeah? So remember these 2 things. Yeah, if you do that, then you stand a much greater chance of getting viable samples. Okay, the molecular side. So traditional race analysis, which you're going to hear a lot more about in the coming days. I mean, this is giving us, most of the information. It will continue to do so. But there are issues about shipping live samples, all the permits and everything that's needed, samples getting lost, all this sort of stuff. Lab capacity, all the labs are struggling with capacity. They can't handle all the samples that are being sent. So now molecular diagnostics, this is a new option that we have. Give us useful information. So Dr. Les Szabo at Minnesota, the Cereals Disease Lab, he's developed a diagnostic SNP assay focused on the UG99 race group. The way the assay works, stage 1 says yes or no, this is UG99 race group in 48 hours. So if a sample came up, say, in India tomorrow, with this assay, in 2 days, you could say yes or no, this is UG99. And that's pretty useful information. He's got a second stage assay which will indicate which of the UG99 races it actually is. And he's also expanding this assay to other races. So this Digaloo race we've got in Ethiopia, his assay is working for that race as well. So these are useful tools. So for DNA samples, what we're after is a single pustule. Yeah? So we'd cut a single pustule, we'd take out the stem tissue, we'd put it into a Eppendorf tube, we'd add ethanol to kill it, we'd leave it sitting for 5 to 7 days, we'd pour off the ethanol, dry it, and then we can send the sample for analysis. And we don't need a permit to send these samples. They're dead, sterile samples. So, yeah, that's a big advantage as well. Similarly, yellow rust. Dr. Sajid, so he has the option to be able to run molecular analysis on dead yellow rust samples. Okay, so this is new. Yeah, you're the first group that has been exposed to this. So really grateful to Sajid. So again, we're looking for a single isolated lesion. We can cut out into an Eppendorf tube, kill it with alcohol, let it sit, decant the ethanol, dry it, and then it can be sent to Sajid for analysis. Okay? Barbary, once again, Sajid, he's able to do molecular analysis on Barbary. So again, either pycnia on the upper surface or ischia on the lower surface. We can cut out an isolated, in this case, ischia into an Eppendorf, add the ethanol, same procedure. Yeah? Don't put pycnia and ischia into the same tube. Yeah? Only either single ischia or a single pycnia. Okay? So don't mix them up in the...
If it is the same leaves, so you have on the upper side Picnia and lower Asia. Normally when the Picnia will dry, then you will have Asia. But don't put the two different clusters in the same.
Yeah.
But you would have some Picnia.
Sorry?
You would have some Picnia spores in
It doesn't make any problem if it is the same cluster.
Yeah. Yeah, but if not to collect, you know, one Picnia from one part of the leaf and then Ischia from the same leaf and mix them into the same tube. Yeah. Okay, for the host, we also have options for running molecular markers in terms of which resistance genes can be present in the host. So here, again, a protocol very similar. It's just cutting a bit of leaf tissue, killing it in ethanol, drying it, and then Robert, his lab can handle these samples. And there are other labs as well, but Robert's lab certainly can take host material, but you do need permits, yeah? So you can't just send these straight to Robert. Live Barberry samples. So here, collecting infected leaves, yeah? Again, glycine or paper, no plastic, same reasons, yeah? Dry, yeah? No moisture with these. Label the envelopes, dry the samples, yeah? And it's probably even more critical with these, yeah? They retain more moisture than the rust samples. Same, send as soon as you possibly can, yeah? The viability of these, getting viability from Barberry is, they're much less robust than the rust spores. Here, it's Dr. Eugene in Minnesota, Cereals Disease Lab. He can receive samples, but you have to have the permits, yeah? So I have the right permits and the pots and for collecting Barberry. So I'll be trying to collect some Barberry on this trip, and they'll be going under permit to Dr. Eugene, yeah? And then with these, like you saw in the video, it'll be trying to infect those ID sets of, you know, wheat, oats, barley, rye, yeah, in the greenhouse. Okay, sending samples. I mean, this is just really for your information. We have a protocols manual, so you'll get copies of the slides, so you have all these links. And then the key people for the different samples and their emails, yeah? The people who you should be contacting about samples, at least the key ones.